Today we're going to introduce code coverage. Our team members are Yuanting Lu, Adrian Wetton, and Scott Mallon. What is code coverage? It is important to know how much of your code is exercised by the unit test. Code coverage tools give you a measure of what percentage of your code has been covered by a unit test run and can highlight in red any statements that have not been covered. Low coverage means that some of the logic of the code has not been tested. High coverage does not necessarily imply that all combinations of input data will be correctly processed by your code, but it nevertheless indicates that the likelihood of correct processing is good. There are 4 types of coverage. Method coverage: how many of your method have been called by your test cases. Statement coverage: how many of your statements have been run by your test cases. Decision and branch coverage: how many decision points of statements have been evaluated both true and false. Condition coverage: how many Boolean sub-expressions have been evaluated both true and false at a decision point. Measuring code coverage allows to identify code insufficiently tested, identify missing tests or unnecessary code, and determine a quantitative measure of code coverage. The disadvantage is that code coverage alone does not ensure good quality. You still need to look at the quality of tests to confirm whether the code coverage metrics is meaningful. Also, if a mistake was made, it is expensive to fix it after the operation. Plus, we need to be cautious about the unusual input data or condition that can't be tested properly. There are many code coverage tools out there, such as Covetra, AMA, Code Coverage, etc. And this is how it looks like in IntelliJ. This is an IntelliJ IDEA code coverage runner. Code coverage in IntelliJ allows you to see the extent to which your code has been executed. It also lets you to verify the extent to which your code is covered by unit tests, so that you can estimate how effective these tests are.
Code coverage is used in the unit testing lifecycle. Unit testing is when individual components within the software are verified and validated. During this process, we need a way to measure how much progress has been done versus how much work is still needed to be completed. That's where code coverage comes in. Subdividing the code, testing for defect discovery, and testing specific properties or conditions are all topics mentioned in Sweetbox Chapter 4. Function coverage, which is another type of code coverage, tests many lines of code and groups of code to verify the expected outcome. This type of code coverage, along with the others listed and mentioned previously by Lou, go hand in hand with the above mentioned topics. Testing teams, specifically individuals within unit testing, are generally the ones involved with coding or with code coverage. Verifying and validating pieces of code within software are their responsibilities, along with measuring the amount of testing completed.
Before coverage testing takes place, the system needs to be broken down into smaller modules and tested. These smaller modules are called unit tests. Each unit test covers the components of a specific module or section of the program. The unit tests need to be done before checking for code coverage because the code coverage will not tell you if the individual components are functioning exactly as intended. They just help find the lines of code that were not called when going through the tests. Integration tests have also typically been done before checking for code coverage to make sure that the individual components are also working together. They can also happen after if the testing team is only focused on the smaller parts of the application. But for code coverage to be of any use, the correct input and outputs need to be checked for and tested for. Then once that has been checked, it's okay to begin checking for how much of the code was covered in the tests that were created. This can give the test team greater insight as to where bugs have a possibility of residing. For an example, the image on the right was taken from CS124. A unit test would need to check this function call and make sure if the proper input would result in the correct output. Code coverage would just check to see if the lines of codes were called during the test. So, if the unit test did call the function using something similar to line 108, then lines 101, 102, and 104 would not be called, which would result in about 50% of the code not being covered. The lines that were not called could then be shown in a report that will help the team by giving them insight as to where something may be overlooked. In this example, it may be the fact that they did not check the function with Sue's balance being greater than Sam's, which might also help them see that there was no check created to return a value if both of the balances were equal. As you can see, code coverage should not be used to check if the system is functioning as it should, but it's merely a tool to help the testing team find potentially hidden bugs in the components that were not fully checked. In addition to code coverage, system acceptance testing should still be done in order to test the quality of the whole system and make sure the needs of the user are still being met through the application. Thank you guys for watching our presentation about code coverage, and we hope it helps you understand a little bit more about what it is and how it works.